Hi there, my name's Ettie and I work for a company called Cookpad, and I'm going to talk with my colleague Nadine today about scaling a machine learning social feed with feature pipelines. So this is Cookpad. We're the world's largest recipe sharing app, and we have an office in Tokyo which looks after the Japan platform, and an office in Bristol in the UK where we look after the global platform. So I'm going to go back and tell a story about when we tried to introduce machine learning into the social feed for the app in 2019. So at this time, the feed service for the application was a Ruby on Rails application backed by Redis and Postgres. And we wanted to introduce machine learning ranked feed for a very small percentage of our users. And to do this, we went through the standard process that we use in the company to test new functionality. And at the end of this experiment, we would decide whether to roll out to our full user base or to drop the functionality because the experiment wasn't a success. So at the time, most of our machine learning had been for research. So we introduced a very simple architecture to be able to extend this to serve production traffic. On the offline side, we were running jobs on Heroku, which is a workflow engine to ingest data from Amazon Redshift and store that in S3. Then the machine learning researcher would fetch that data from S3, calculate a number of features. So these typically were embeddings for different bits of data that had been fetched from the data warehouse. And then they would use these embeddings to train a model to rank recipes to be personalized for these users, and then calculate these ranked recipes and store them back to S3. On the online side, when a customer would come in and make a request to the machine learning feed, so this is users who are in the experiment, we were just serving this through a very simple Python application, which was storing pre-ranked recipes for users in the experiment in memory. So when we looked at the results of this experiment, and we were measuring metrics by an aggregate of interactions that users were making on the feed, so whether they were clicking on recipes, liking them, saving them to come back to later. When we looked at these metrics, we got an over 30% increase on the interactions that we cared about on the ML ranked feed. So naturally, the product managers were very pleased about this result, and they asked us when we could roll this out to 100 million users. So obviously we had to say no, because this was a very simplistic architecture and it wasn't going to scale to that user base. So where are the bottlenecks? So on the serving side, we were storing ranked recipes in memory. As this data grows, the service would have really long startup times. You have to replicate the data every time you want to replicate your service. So when you want to scale out horizontally, and you have to calculate and store ranks even for silent users. So a large proportion of our users never log into the app, and we don't want to be calculating data for them. On the training side, there was a lot of manual repetition. So the researcher would have to recalculate their feature data every time they wanted to run an experiment. And because of the way we were storing data, it was sometimes hard to share this feature data between team members. So we've rethought how we want to do this, and Nadine is going to talk about the solution that we are using today.
Hi everyone, I'm Nadine, and I will be taking you through how we scaled our social feed to 20 million users. So at first, the main functionality of the social feed is to recommend recipes that our users might interact with. Therefore, it's a read-heavy application and also requires the fastest response time possible in milliseconds. In addition, the number of requests vary for example, in time of day and the most popular events of the year. Hence, we have chosen to store our ML feature in DynamoDB with DAX, which made our application fast and responsive, even when a popular event occurs like now during Ramadan. To populate machine learning features, we started with cron jobs through Argo workflows. that are ingesting data in batches into our feature store. Unfortunately, these jobs are using the recipes published the day before, since they are consuming data from Redshift. In order to use fresh content as soon as they are added to our platform, we are recently gradually shifting the streaming ingestion system that will produce and store machine learning feature in nearly real time, so we can make sure we are using them as soon as possible. And these cron jobs are using also, as we can see here, feature extraction services. Like, for example, in our case, mainly, there are recipe embeddings and user embeddings. Finally, to address disaster recovery that might occur for our feature store, we are using point-in-time recovery, which will automatically back up the data with per-second granularity, so that we can restore it to any given second in the previous 35 days. We can say that the main advantage of the point-in-time recovery for the DynamoDB is that it doesn't affect the read capacity or the availability of our production table. So we can say that we are still using it with no problem. So basically, what Feature Store has enabled us to is first rolling out to 20 million reliably versus 10,000 users during our first experiment in 2019. We can also now say that our service is retrieving pre-calculated features rather than, as Ettie said, we had before need to calculate all this feature every time we are using the service. Using DAX, we can say that we increase data retrieval performance, which, as said, has enabled us to run faster. And finally, we can say that Feature Store has enabled us to have a stable service even when we get a bump of traffic now during Ramadan, which is 2.5. On the other hand, it also had a very positive impact internally, as it has enabled the research team to collaboratively develop new models faster by reusing shared features. So recently, we have been able to do four new experiments due to our feature store. For example, we can see here that during Ramadan and even during a traffic spike, our system was reliable. We can see that no failed responses. And also our DAX cluster is being highly used. Thank you for all listening and hope that this lightning talk had give you some idea how you can use your feature store to make an application that has ML inside more faster and reliable. If you are interested in Cookpad, please, we have always new openings, and this is our website, and hope your talk find you well. Thank you.